Located inside IKEA's circular hub, there are many used and castaway parts from IKEA products. Here we see panels from IKEA cabinets. In this video, we will turn a panel into a small table using PVC pipe and 3D printed leg brackets. This video was created as an addendum for the book Simplifying 3D Printing with OpenSCAD by Colin Dow. Please be sure to like our video and subscribe to our channel so that we can continue to make more videos. We will start by measuring the inside and outside diameters of our PVC pipe. We will call these measurements inside diameter and outside diameter respectively. We measure and record the thickness of the panel as panel thickness in our code. Taking the measurement of the threaded part of our screw, we can see it equal to 15 millimeters. We record this value as screw length. To add a chamfer to our parts, we require a variable to store the chamfer value. For our design, we set this value to 10. The variable post height stores the value of the height of the inside post from the bottom of the bracket to the start of the chamfer. To secure the bracket to the bottom of the panel, we want the screws to screw into half the thickness of the panel. This will provide a strong connection and keep the screw from deforming the other side. For this, we need to ensure that the screw sticks out from the bottom of the bracket by an amount equal to half the panel thickness. To do this, we calculate a value we call countersink to be equal to the screw length minus panel thickness divided by 2. Countersink will be the thinnest part of the base. The module Create Chamfer produces a cone-shaped cylinder to act as a chamfer. It does this by creating a cylinder with a large diameter equal to the inside diameter of the PVC pipe and a small diameter equal to the inside diameter minus the chamfer value. The height of the chamfer cylinder is also equal to the chamfer value. A variable named factor is used to modify the size. It is set to a default value of 1. The module generates screw holes, uses cylinders for different operations to create screw holes. The module takes in 2 parameters, numbscrews and distance, which controls how many cylinders are generated and their placement from the central origin. Countersink determines the z-axis value for the larger cylinder and thus the amount of countersink for our leg bracket. The module Create Leg Bracket generates the bracket that sits under the panel and holds the PVC pipe legs in place. The module takes the values for numbscrews and base diameter. By placing these values here, we allow easy adjustments to the number of screws and their placement on the bracket as they are set in the call to the module. A call to the Create Chamfer module creates and places a chamfer on top of a cylinder with a diameter equal to the inside diameter of the PVC pipe and a height equal to post height. We use a difference operation to cut out the screw holes from a base created by a cylinder set to base diameter. Note the value of 5 added to the countersink value. This will set the thickness of the base to countersink plus 5 millimeters. As well, note that the distance of the screw holes from the origin is set to 40% of the base diameter. We use end caps on the bottom of our PVC pipe legs. To generate the end caps, we use the module Create End Cap. This module takes a parameter called scale factor, which is used to modify the height of the inside post and the outside lip. A chamfer is placed on top of a cylinder with a diameter equal to the value of inside diameter and height of post height as set in the variable declarations. A second cylinder with a diameter equal to outside diameter and a height set to 40% of post height provides the lip for the end cap. In OpenSCAD, we pass the values of 4 and 100 into the Create Leg Bracket module to create a leg bracket with 4 screw holes and a base diameter of 100 millimeters. We then render our design by hitting F6 on the keyboard and export to an STL file by hitting F7. For the end caps, we pass the value of 0.5 into the Create End Cap module to create an end cap with the post and chamfer height half of the leg bracket. We then proceed to render and export using F6 and F7 respectively. We print out our design in PLA using a Creality Ender 2 3D printer on a steel spring flexible build plate. We cover the build plate with masking tape and a layer of glue from a glue stick. For slicing, we modify the default PLA template in IKEA'S. For infill, we set the infill density to 30% and the infill line multiplier to 2. Under the Materials section, we set the printing temperature to 210 degrees Celsius and the build plate temperature to 70 degrees Celsius. For build plate adhesion, we set the build plate adhesion type to skirt. We use the same IKEA'S settings for both the leg bracket and end cap. 4 pieces for each part are required. For the end caps, all 4 pieces may be printed at the same time. To assemble the table, secure the leg brackets at the corners of the panel. Be sure to use the side where any pockets may be cut out. Use pilot holes if desired. Once the leg brackets are secured, slide the PVC pipes with end caps onto each bracket. If present, remove the protective film from the panel. Our table is completed.